Insecticides are another group of chemicals that toxicologists deal with. We'll look at some of the problems that have arisen from insecticides in birds in this next section. The book Silent Spring was published in 1962, and it really was the foundation for the environmental movement that made such a difference in cleaning up toxic contamination in the United States. A lot of the problem that was reported on in the book was related to pesticides. And Rachel Carson, an excellent writer who really referenced good sources on the material in the book, had linked pesticides to serious illnesses and deaths in many different ways. Now, she was attacked by the chemical industry, and they called her names like alarmist and hysteric. But she had credibility, and she testified before Congress and called for new policies to protect human health and the environment. So, really, one toxicology. She did this even though she was fighting breast cancer, and she died only 2 years after the book was published. Before too long, in 1970, the US EPA was founded, and most of the laws that protect the environment followed soon thereafter. It was a heyday in improving the environment in the United States. After World War II, dichlorodiphenyl trichloroethane, or DDT, became a globally important insecticide. Its neurotoxic mechanisms of action, its estrogenicity, its anti-androgenicity, its effects on eggshells were unknown at that time. But effects on birds began to appear nonetheless in terms of population declines. Brown pelicans, bald eagles, peregrine falcons, and other birds that feed at the top of aquatic food webs were devastated. The osprey, another fish-eating bird, was similarly harmed. Low concentrations in water accumulated in aquatic plants, and from there it went up the food web, first to the invertebrates, then the small fish and the larger carnivorous fish, and finally into the large top predator fish and the avian predators and other species that relied on them. Organohalogen molecules like DDT, other organochlorine insecticides, other organochlorine compounds used for other purposes like polychlorinated biphenyls, accidentally produce compounds like dioxins and dibenzofurans. Compounds that are neutral in charge and highly fat soluble and difficult for the body to metabolize tend to work their way up these food webs with extraordinary biomagnification, such that thousands of times higher concentrations wind up in the top predators than in the lower levels of the food web. Here we see the first bioaccumulation step followed by the biomagnification steps above. Oftentimes when animals are building up their fat deposits, there's not a great impact, as the molecules are largely isolated in the lipid reservoirs. But when they start to become catabolic, like when they're migrating or egg laying, or when they're pregnant or lactating, then the molecules come back into the circulation, and if this is a reproductive stage, they move into the young. And the firstborn young of top predators feeding in a contaminated aquatic ecosystem, they are oftentimes massively exposed to toxic chemicals that do them harm. After Silent Spring and the establishment of the environmental movement and the regulations and a great deal of research in field and laboratory settings, DDT and many other persistent pesticides that harmed wildlife and threatened human health were banned. After DDT was banned in 1972 and the compound gradually broke down in the environment, species like the bald eagle, the peregrine falcon, and other fish-eating birds made a recovery. Today, some of the most important categories of insecticides in the market are fipronil and neonicotinoids, sometimes called neonics. One of the reasons that birds are so susceptible to insecticides is their high metabolic rates. Because of that, they have to eat a lot, and so they are exposed to higher levels of foodborne toxicants. When they cannot feed because of neurotoxicity or neurologic effects or other effects that make them unable or unwilling to eat, or when they have too little food because their insect food base has been depleted, then they wind up with malnutrition or starvation. So they're going to lose body condition in a hurry. Any species that cannot eat for a prolonged period of time or is neurologically disrupted will be stressed. Chronic stress can, in the case of birds, cause the elaboration of corticosterone. This is going to cause immunosuppression, and it will tend to increase the probability of infectious diseases. This depicts normal events in a presynaptic neuron, a postsynaptic neuron, and a synaptic cleft. Depolarization associated with sodium entry is somewhat counteracted by potassium leaving through potassium channels. With the more positive charge from the sodium entry, you wind up with release of acetylcholine, which then opens another sodium channel. On the other hand, acetylcholine is broken down by acetylcholinesterase. And also, chloride comes in to try to tamp down the process as well. But if the positive charges of the sodium ion are sufficient, the impulse is conducted, more voltage-gated channels, sodium channels open, and the process continues downstream. Here we see the effects of fipronil, which blocks GABA-mediated and glycine-mediated receptors that are involved with chloride channels. So what happens here is that there's interference with the ability of chloride to enter. The chloride channels do not open. So the birds are overly stimulated, and they wind up with effects like dropping their wings, tremors, and seizures. In this case, birds vary in their susceptibility. For example, quail and other related galliform birds are very sensitive, whereas ducks are more tolerant. Fipronil is more selective than the older DDT and other organochlorine insecticides. It's not as highly biomagnified as they were, and it's more toxic to insects than to birds. But it's not selective enough to avoid some direct avian toxicity. It's neurotoxic, and it's also thyrotoxic. It's directly lethal to birds that ingest pre-treated seeds. And sublethal exposures from treated seeds can also cause a problem. Problems like reduced body weight, impaired cellular immunity, reduced carotenoid-based coloration, reduced steroid hormone levels, and impaired reproduction. Also, surviving offspring have had reduced cellular immunity. In addition, fipronil is toxic to insects and potentially fish, lizards, and small mammals that can serve as the prey of birds. So they wind up with malnutrition, stress, and impaired reproduction, even if they're not directly poisoned by the pesticide. There certainly is a need for more research of the impacts of fipronil on predatory birds. The neonicotinoids, also called neonics, like imidacloprid and clothianidin, act much in the way that nicotine itself does. They open sodium channels, but they're not broken down by acetylcholinesterase, so they wind up causing stimulation. And these effects would be seen including at neuromuscular junctions. The neonicotinoids, like imidacloprid and clothianidin, are unlikely to biomagnify, and they are less toxic to birds than to insects, but still they're not selective enough to avoid some lethality. Problems occur from direct exposure from spraying, and sensitive birds can die. Ingestion of a few treated seeds will also kill granivores. An example was November of 2016 when hundreds of red-winged blackbirds and other species were killed after they consumed imidacloprid-treated wheat seed that had been broadcast on a field in New Jersey. Effects on birds include stimulation, ataxia, and crash injuries. They may also have paresis, paralysis, and apathy, certainly those problems would contribute to increased likelihood of them suffering from predation. Additional concerns with neonicotinoids, and some of these occur at very low doses, are genotoxicity and reduced immunity, growth, and reproduction. As with many other insecticides, they also deplete invertebrate prey, so insectivores can have a real problem. And in the Netherlands, areas that had high imidacloprid use and water contamination had declines in insectivorous birds that rely on aquatic insects. They lost about 3.5% in their counts per year. Fipronil and neonicotinoids are neurotoxic to bees, and this has raised some important concerns. The neonicotinoids seem to cause addiction in bees, just as nicotine causes addiction in people. What happens with these neurotoxic responses is the honeybees apparently lose their ability to find their way back to hives. Bumblebees are especially susceptible, and bees have fewer young. They also experience more infectious diseases, so there's some form of immunosuppression at work. Now, with these concerns and others, the US EPA banned fipronil from corn seed treatment in 2009. In 2013, Europe severely restricted both the neonicotinoids and fipronil. In 2015, Montreal banned neonicotinoids. In 2017, Europe banned fipronil from agriculture. And in 2018, and I think continuing into 2019, the US neonicotinoids are being reviewed by the EPA in the United States. We have to ask ourselves, what if fipronil neonicotinoids were withdrawn from the market? Well, other insecticides would in all likelihood be used. Some of them are still on the market that cause problems, like chlorpyrifos. We would be concerned about its effects on non-target species, wildlife, domestic animals, and people as well. Still, we have to have some pressure to move forward with more selective pesticides, highly selective insecticides that target the pests, not the insects that prey on them, and certainly not the birds, the bats, or the other insectivorous vertebrates. We can use integrated pest management, which is more selective use, more careful use, more prioritized use of pesticides and to lessen effects. We can also use integrated biodiversity management to protect more species. That involves things like crop rotation, better selection of crop varieties, companion planting to support predatory insects, and insect traps and pheromones to figure out when insecticides are absolutely needed and what the economic threshold is for their application. So scientists are working on this, but it's an ongoing challenge. And pressure to minimize impacts on wildlife drives, and on other species, drives research, innovation, and protection. Getting involved in this, including with industry, is a way to make a difference, to get safer products on the market, so that people have food, so that pests are controlled, so that other species are protected.